Hello friends, welcome to Premier UPSC IAS. So today we are going to discuss about the geography part of UPSC Prelims IAS exam. The geography static part only. In this lecture, we are going to cover only the important topics pertaining to the prelims examination, and only those points which can come as a question in the exam will be covered. So let's dive into the topic directly. The universe. Introduction. The universe is made up of space and time, and their contents include planets, stars, galaxies, and all other forms of matter and energy. The earlier scientific models of the universe, geocentric model, Earth at the center of the universe, developed by Greek and Indian philosophers. So obviously this is a wrong model. Heliocentric model, Sun at the center of the solar system, developed by Nicholas Copernicus. Space and time emerged together 13.7 billion years ago with a fixed amount of energy and matter that has become less dense as the universe has expanded. From studying the movement of galaxies, it has been discovered that the universe contains much more matter than is accounted for by visible objects, stars, galaxies, nebulae, and interstellar gas. This unseen matter is known as dark matter. Dark means that there is a wide range of strong indirect evidence that it exists, but we have not yet detected it directly. The Big Bang Theory. The Big Bang Theory is an effort to explain what happened at the very beginning of the universe and also explain what happened during and after that moment. According to the standard theory, our universe sprang into existence as singularity around 13.7 billion years ago. Singularities are zones which defy our current understanding of physics. They are thought to exist at the core of black holes. Black holes are areas of intense gravitational pressure. The pressure is thought to be so intense that finite matter is actually squished into indefinite density. These zones of infinite density are called singularities. The Big Bang Theory. Galaxies appear to be moving away from us at speed proportional to their distance. This is called Hubble's law, 1929. This observation supports the expansion of the universe and suggests that the universe was once compacted. If the universe was initially very hot, as the Big Bang suggests, we should be able to find some remnant of this heat. In 1965, radio astronomers discovered a 2.725 degree Kelvin cosmic microwave background radiation (CMB) which pervades the observable universe. Finally, the abundance of the light elements hydrogen and helium found in the observable universe are thought to be support the Big Bang model of origins. Galaxies and its type. A galaxy is a huge collection of gas, dust, and billions of stars and their solar systems. A galaxy is held together by gravity and a supermassive black hole in the middle. Types of galaxies: spiral, elliptical, and irregular galaxy. Spiral galaxies are consist of a flat disk with a bulging center and surrounding spiral arms. The galaxy's disk includes stars, planets, dust, and gas, all of which rotate around the galactic center in a regular manner. Milky Way. It is our home galaxy in the universe. It is a fairly typical barred spiral with four major arms in its disk, at least one spur and a newly discovered outer arm. It began forming around 12 billion years ago and is part of a group of about 50 galaxies called the Local Group. The Andromeda Galaxy is part of this group as there are numerous smaller galaxies including Magellanic Clouds. Elliptical galaxies. Elliptical galaxies are shaped as their name suggests elliptical. It contains many older stars up to 1 trillion but little dust and other interstellar matter. The stars orbit the galactic center like those in the disks of spiral galaxies, but they do so in more random directions. Irregular galaxies. Galaxies that are not spiral or elliptical are called irregular galaxies. Irregular galaxies appear misshapen and lack a distinct form, often because they are within the gravitational influence of other galaxies close by. Solar system. The solar system is the gravitationally bound planetary system which consists of the following: the Sun, the eight planets, dwarf planets, more than 190 satellites of the planets, a large number of small bodies, the comets and asteroids, and the interplanetary medium. The Sun is a yellow dwarf. It was formed about 4.6 billion years ago and it is a star. It is made up of following elements: hydrogen 74.9%, helium 23.8%, and metals 1.3%. Structure of the Sun. The structure of the Sun can be divided as the following: inner layers, a core at its center, a radiative zone surrounding the core, and a convective zone surrounding the radiative zone. Outer layers, a thin photosphere at its surface, a chromosphere, the corona that extends beyond the photospheric surface. Corona is the outermost layer of the Sun. Chromosphere and corona are visible only during the formation of diamond ring during the solar eclipse. Solar spots are temporary dark spots formed when the magnetic field bursts through the surface. Inner and outer planets. The eight planets in our solar system are divided among two categories in order to distance from the Sun, such as inner planets, also called as terrestrial, and they are closest to the Sun: Mercury, Venus, Earth, and Mars. Outer planets, also called as gaseous, farthest to the Sun: Jupiter, Saturn, Uranus, and Neptune. And between those two, there is the asteroidal belt, specifically speaking, between the Mars and the Jupiter. Mercury. It is the closest planet to the Sun. It takes 88 Earth days to complete one revolution around the Sun. However, it takes 59 Earth days to complete one rotation. And the length of the day on Mercury, sunrise to sunrise, is 176 Earth days. Mercury's very thin atmosphere is made primarily of sodium, potassium, helium, and hydrogen. Venus. It is similar to Earth due to its size and composition. So it is also called Earth's sister planet. To complete one revolution and rotation needs 225 days and 243 days respectively. Interestingly, this is even hotter than Mercury, which is much closer to the Sun. This is because of a runaway greenhouse effect on Venus. Earth. Theories of the origin of the Earth. Nebular hypothesis. Planets were formed out of a cloud of material associated with a youthful sun which was slowly rotating. Big Bang Theory. Edwin Hubble in 1920 provided the evidence that the universe is expanding. At the stage 1, universe is the form of tiny ball singular atom. And as the time passed, second stage Big Bang event, tiny ball explosion took place 13.7 billion years ago, energy converted into some matters. Then the third phase, within 3000 years from the Big Bang, temperature dropped to about 4500 kelvins, gave rise to atomic matter. Structure of the Earth. The structure of the Earth can be divided as the following: the crust, outermost part; mantle, middle part; and the core, innermost part. Crust, the code word is Sial. The thickness of the crust varies under the oceanic and the continental areas. Major constituent elements of the crust are silica Si and aluminium Al, known as Sial. The Conrad discontinuity is between the hydrosphere and crust. Mantle, the code word is Sima. The portion of the interior beyond the crust is called the mantle. The upper portion of mantle is called asthenosphere. It extends from Moho's discontinuity to a depth of 2,900 kilometers. This layer is the main source of magma volcanic eruption. M for magma, M for mantle. It has a density higher than the crust. The major constituent elements of the mantle are silicon Si and magnesium Ma, and it is known as SEMA. Mohorovic discontinuity or Moho discontinuity between the crust and the mantle. Core. The code word is knife. The core mantle boundary is located at the depth of 2,900 kilometers. The outer core is in a liquid state while the inner core is in a solid state. The density of a material at the mantle core boundary is around 5 gram per centimeter cube, and at the center of the earth at 6,300 kilometers the density value is around 13 gram per centimeter cube. The core is made up of a very heavy material mostly constituted by nickel and iron, hence NIFE, knife. It is sometimes referred to as knife layer. The discontinuity between the upper core and the lower core is called the Lehman discontinuity. Mars. It is known as the red planet because due to the high concentration of iron oxide compounds in the rocks of the Martian surface. The year is of 687 days and day is of 24 hours and 37 minutes longer than a day at the Earth. The atmosphere is made up of mostly carbon dioxide with tiny fractions of oxygen, nitrogen, and other gases. The tallest mountain in the solar system, the extinct volcano Olympus Mons, moons of Mars are Phobos and Deimos. Jupiter is the largest planet in the solar system. It consists of hydrogen and helium. A day is 9 hours 56 minutes, so the fastest rotating planet. As of now, there are 79 known moons of Jupiter. However, four of them, Io, Europa, Ganymede, and Callisto, are about the size of the Earth's moon or larger. The red spots are red in color because of sulfur or phosphorus. Saturn. A day is 10 hours and 39 minutes long. Its atmosphere layers consist of liquid hydrogen and helium. Saturn has 62 confirmed moons and its largest moon is Titan. Uranus. Uranus is similar in composition to Neptune. Its primary composition of hydrogen and helium, but it contains more ices such as water, ammonia, methane, along with traces of other hydrocarbons. Neptune. Neptune takes 165 Earth years to orbit the Sun once. A day is 16 Earth hours. It is bluish green in color. Its atmosphere consists mostly of hydrogen, helium, and methane. Asteroid belt. The asteroid belt is the circumstellar disk in the solar system located roughly between the orbits of the planets Mars and Jupiter. Hence, the vast majority are found in a region of the solar system out beyond Mars. They form the asteroid belt. The asteroid belt objects are made of rock and stone. The four largest asteroids in the belt are Ceres, Vesta, Pallas, and Hygiea. Gravitational influences can move asteroids out of the belt. Dwarf planets. A dwarf planet is a celestial body that has the following characteristics. It lies in orbit around the Sun. It has sufficient mass for self gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium nearly round shape. It has not cleared the neighborhood around its orbit. More importantly, a dwarf planet is not a satellite. It shares the same characteristics as planets, though there is one significant difference. The key difference is that a planet has cleared objects in the area of its orbit, while a dwarf planet has not. There are five officially recognized dwarf planets in our solar system. They are the following: Ceres, Pluto, Haumea, Makemake, and Eris. In 2015, NASA's Dawn and New Horizons missions reached Ceres and Pluto respectively. Kuiper Belt. It is similar to the asteroid belt but exists beyond the eight major planets. Similar to the asteroid belt, the Kuiper Belt is a region of leftovers from the solar system's early history. Like asteroid belt, it has also been shaped by a giant planet, although it's more of a thick disk like a donut than a thin belt. The Kuiper belt shouldn't be confused with the Oort cloud, which is a much more distant region of icy comet-like bodies that surrounds the solar system, including the Kuiper belt. It also is home to the known dwarf planets like Pluto, Haumea, and Makemake. Oort cloud. Oort cloud is an extended shell of icy objects that exist in the outermost reaches of the solar system. Spherical in shape and is thought to be the origin of most of the long period comets that have been observed. Moon. It is Earth's only natural satellite and a nearest large celestial body. The moon orbiting Earth have a close point called perigee and a far point called apogee. The period of revolution around the Earth is 29.53 days synodic month. It is similar to the period of revolution of the Earth and the main reason to get the view of the only one side of the moon from the Earth always. Meteoroids. Meteoroids are objects in space that range in size from dust grains to the small asteroids. Meteoroids can be considered as space rocks. When meteoroids enter Earth's atmosphere at high speed and burn up, the fireballs or shooting stars are called meteors. When a meteoroid survives a trip through the atmosphere and hits the ground, it is called meteorite. Almost all the material is vaporized in Earth's atmosphere, leaving a bright trail fondly called shooting stars. Sometimes the number increases dramatically. These events are termed meteor showers. Star formation. Stage 1 are the development of galaxies due to the accumulation of matters drawn from the different gravitational forces. Stage 2 formation of cloud nebulae. Accumulation of hydrogen gas in the form of a very large cloud forming a nebula. Stage 3 formation of stars. Growing nebula develops localized clumps of gas, further grow into denser gaseous bodies, giving rise to formation of stars. Oceans and continents. Continental drift. Continental drift was a theory that explained how continents shift position on Earth's surface. In 1912, Alfred Wegener, a geophysicist and a meteorologist, explained the continental drift as for why look-alike animal and plant fossils and similar rock formations are found on different continents. Continental drift theory. According to Wegener, all the continents formed a single continental mass surrounded by the mega ocean. The single continent was named Pangaea, which means all earth. The mega ocean was called Panthalassa, meaning all water. Pangaea first broke into two large continental masses as Laurasia and Gondwana land, forming the northern and southern components, respectively. Subsequently, Laurasia and Gondwana land continued to break into various smaller continents that exist today. Continental drift evidences. A variety of evidence was offered in support of the continental drift. Some of these are given below. The matching continents jigsaw fit. The shorelines of Africa and South America facing each other have a remarkable and unmistakable match. Second one, rocks of same age across the oceans. The belt of ancient rocks of 2000 million years from Brazil coast matches with those from the Western Africa. Third, stilite. It is a sedimentary rock formed out of the deposits of glaciers. The Gondwana system of sediments from India is known to have its counterparts in six different land masses of the southern hemisphere, that is, Africa, Falkland Island, Madagascar, Antarctica, and Australia. Placer deposits. The gold-bearing veins are in Brazil, and it is obvious that the gold deposits of Ghana are derived from the Brazil Plateau when the two continents lay side by side. Distribution of fossils. When identical species of plants and animals adapted living on land or in fresh water are found on either side of the marine barriers, a problem arises regarding accounting for such distribution. Lemurs occur in India, Madagascar, and Africa. Let's some to consider a contiguous landmass Lemuria linking these three landmasses, that is India, Madagascar, and Africa. Wegener suggested that the movement responsible for the drifting of the continents was caused by pole fleeing forces and tidal force. The polar fleeing forces relates to to the rotation of Earth. Plate tectonics major plates. In 1967, McKinsey, Parker, and Morgan independently collected the available ideas and came out with another concept termed as plate tectonics. Accordingly, the major plates are as follows: 1. The Antarctica and the surrounding oceanic plate. 2. North American plate. 3. South American plate. 4. Pacific plate. 5. India, Australia, and New Zealand plate. 6. Africa plate with eastern Atlantic floor, and 7. Eurasia and the adjacent oceanic plate. Plate tectonics. Minor plates. Cocos plate between Central America and Pacific plate. Nazca plate between South America and Pacific plate. Arabian plate mostly in Saudi Arabian landmass. Philippine plate between the Asiatic and the Pacific plate. Caroline plate between the Philippine and Indian plate north of the New Guinea. Fiji plate northeast of Australia. Types of plate tectonics boundaries. There are three types of plate boundaries. Divergent plate boundaries, the two plates move away from each other. Convergent plate boundaries, the two plates move towards each other. Transform plate boundaries, the two plates slip past each other. Divergent plate boundaries. Plate moves apart at mid-oceanic ridges where the new seafloor forms. Between the two plates is a rift valley. Lava flows at the surface and gets cooled rapidly to become basalt, but deeper in the crust, magma cools more slowly to form gabbro. So the entire ridge system is made up of igneous rock that is either extrusive or intrusive. Earthquakes are common at mid-ocean ridges since the movement of magma and oceanic crust results in crustal shaking. The ultimate divergent boundary is the Atlantic Ocean, which began when Pangaea broke apart. Convergent plate boundaries. When two plates converge, the result depends on the type of lithosphere the plates are made of. Smashing two enormous slabs of lithosphere together results in the creation of magma and earthquakes. Ocean to continent convergence occurs when the oceanic crust converges with continental crust, forcing the denser oceanic plate to plunge beneath the continental plate. This process is called subduction. Examples: the Philippine Islands and the Aleutian Islands of Alaska. An oceanic to oceanic plate boundary occurs when two oceanic plates converge, causing the older, denser plate will subduct into the mantle. The Ring of Fire is a ring around the Pacific Ocean of subduction zones, which most are oceanic to oceanic convergence. Examples: Japan, Indonesia, and the Aleutian Islands. Continental to continental convergence occurs when two continental plates converge instead of subduction. The two similar tectonic plates will buckle up to create large mountain ranges like a massive car pileup. Examples of mountain ranges created by this process are the Himalayan mountains as Indian plate is colliding with Asia, the Alps in Europe, etc. Transform plate boundaries. It occurs when two tectonic plates slide or grind past parallel to each other. The most famous transform boundary is San Andreas Fault, where the Pacific plate, Los Angeles and Hawaii are on it, is grinding past the North American plate, San Francisco and the rest of the United States is on it at the rate of 3 inches a year. Intraplate boundaries. A small amount of geologic activity known as intraplate activity does not take place at plate boundaries but within a plate instead. Location on the globe. The equator. An imaginary line running on the globe divides into two equal parts such as the northern half and the southern half. This line is known as the equator. Northern half of the earth is known as the northern hemisphere and the southern half is known as the southern hemisphere. Latitudes. Latitude is the angular distance of a point on the Earth's surface and measured in degrees from the center of the Earth. All are parallel to one another and never meet. get shorter towards the poles with only the equator as the longest and a great circle. The equator 0 degree, north pole 90 degree north and the south pole 90 degree south. Important parallels of the latitudes. There are four important parallels of latitudes. Tropic of Cancer to 23 and a half north in the north hemisphere, Tropic of Capricorn 23 and a half south in the southern hemisphere, Arctic Circle at 66 and a half north of the equator, Antarctic Circle at 66 and a half south of the equator. Longitudes. To fix the position of your place, it is necessary to know something more than the latitude of that place. Example, Tonga Islands in the Pacific Ocean and the Mauritius Islands in the Indian Ocean are situated on the same latitude, that is 20 degrees south. Now, in order to locate them precisely, we must find out how far east or west these places are from a given line of reference running from North Pole to South Pole. These lines of references are called the meridians of longitude, and distances between them are measured in degrees of longitude. Unlike parallels of latitude, all meridians are of equal length. All countries decided that the meridian count should begin from the meridian which passes through Greenwich, where the British Royal Observatory is located. This meridian is called the prime meridian. The prime meridian and 180-degree meridian divide the earth into two equal halves, such as the eastern hemisphere and the western hemisphere. Example, Dhubri in Assam is situated at 26-degree north latitude and 90-degree east longitude. Longitudes and time. The Earth rotates 360 degrees in about 24 hours, which means 15 degree an hour or 1 degree in 4 minutes. When it is 12 noon at Greenwich, the time at 15 degree east of Greenwich will be 15 into 4, 60 minutes. That is 1 hour ahead of the Greenwich time, which means 1 p.m. But at the 15th, at 15 degree west of the Greenwich, the time will be behind the Greenwich time by 1 hour, that is, it will be 11 a.m. Similarly, at 180-degree, it will be midnight when it is 12 noon at the Greenwich. Standard time and time zone. The local time of the places which are on different meridians is bound to differ. If each town were to keep the time of its own meridian, there would be much difference in local time between the one town and the other. Travelers going from one end of the country to the other would have to keep changing their watches if they wanted to keep their appointments. This is impractical and very inconvenient. To avoid all these difficulties, a system of standard time is observed by all countries. Most countries adopt their standard time from the central meridian of their countries. Example, in India, there will be a difference of about 1 hour and 45 minutes in the local times of Dwarka in Gujarat and Dibrugarh in Assam. It is therefore necessary to adopt the local time of some central meridian of a country as the standard time for the country. In India, the longitude of 82.5 degree east is the standard meridian. The local time at this meridian is known as Indian Standard Time. In larger countries such as the Canada, the USA, the China and Russia, it would be convenient to have a single time zone. So it have these countries have multiple time zones. I'm sorry, it would be inconvenient to have a single time zone. International date line. This is the international date line where the date changes by exactly one day when it crosses the 180-degree meridian. A traveler crossing the date line from east to west loses a day because of the loss in time he has made. And while crossing the date line from west to east, he gains a day because of the gain in time he encountered. Why is the international date line drawn in a zigzag manner? Some group of islands, Polynesia, Melanesia, and Micronesia, etc., fall on either of the date lines. So if the dateline was straight, then two regions of the same island country or island group would fall under different date zones. Motions of the Earth, rotation and revolution. Rotation is the movement of the Earth on its axis. The movement of the Earth around the Sun is in a fixed path or orbit is called revolution. Axis of the Earth, which is in an imaginary line, makes an angle of 66 and half with its orbital plane. The portion facing the sun experiences day, while the other half away from the sun experiences the night. The circle that divides the day from night on the globe is called a circle of illumination. Rotation of the Earth 24 hours, Earth day. Revolution of the Earth around the sun 365 and 1/4 days, 1 year. Earth moves in elliptical order. The year is usually elliptical orbit. A year is usually divided into the following four seasons: summer, winter, spring, autumn. Seasons change due to the change in the position of the Earth around the Sun. Summer and winter solstice, 21st June. On 21st June, the northern hemisphere is tilted towards the sun. The rays of the sun fall directly on the Tropic of Cancer. As a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the sun are slanting. The North Pole is inclined toward the sun, and the places beyond the Arctic Circle experience continuous daylight for about 6 months. Since a large portion of the north hemisphere is getting light from the sun, it is summer in the regions north of the equator. The longest day and the shortest night at these places occur on 21st June. At this time, in the southern hemisphere, all these conditions are reversed. It is winter in the southern hemisphere, nights are longer than the days. This position of the earth is called as the summer solstice. 22nd December. On 27th December, the Tropic of Capricorn receives the direct rays of sun as the south pole tilt towards it. As the sun's rays fall vertically on the Tropic of Capricorn to 23 and a half south, a large portion of the southern hemisphere gets light. Therefore, it is summer in the southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. This position of the earth is called as winter solstice. Equinox. On 21st March and September 23, every year, direct rays of the sun fall on the equator. At this position, neither of the poles is tilted towards the sun. So the whole earth experiences equal days and equal nights. This is just called an equinox. On 23rd September, it is autumn season after summer and before the beginning of the winter in the northern hemisphere, and spring season in the southern hemisphere. The opposite is the case on 21st March when it is spring in the northern hemisphere and autumn in the southern hemisphere. Oceanography. Water on the earth. Water is an extremely important component of all life forms that exist over the surface of the earth. Water is a rare commodity in our solar system. About 77% of the planetary water is found in the oceans, and the remaining is held as fresh water in glaciers and ice caps, groundwater sources, lakes, soil moisture, atmosphere, streams, and within life. The percentage is, by the largest, it is in oceans, 97.25. Then comes the ice caps and glaciers, 2.05. Groundwater is only 0.68, and other are very less compared to the groundwater also. Ocean. There are divided into four oceans, namely the Pacific, the Atlantic, Indian, and Arctic. The various seas, bays, gulfs, and other inlets across the globe are parts of these four large oceans. Major relief features. The ocean floors can be divided into four major relief divisions: the continental shelf, the continental slope, the deep sea plain, the oceanic deeps. Continental shelf. Continent shelf is the extended margin of each continent occupied by relatively shallow seas and gulfs. The shelf typically ends at a very steep slope called the shelf break. The width of the continental shelves varies from one ocean to another, and the average width of the continental shelves is about 80 kilometers. The continental shelves are almost absent or very narrow along some of the margins, like the coast of Chile, the west coast of Sumatra, etc. The Siberian Shelf is in the Arctic Ocean, is the largest in the world and stretches to 1500 km in width. These are covered with variable thickness of sediments brought down by rivers, glaciers, wind from land, and distributed by waves and currents. Continental slope. The continental slope bridges the continental shelf and the ocean basins. It begins where the bottom of the continental shelf sudden drops off into a steep slope. The depth of the continental slope region varies between 200 and 3000 meters, and their boundary indicates the end of the continents. Canyons and trenches are seen in this region. Deep sea plain. The deep sea plains are gently sloping areas of the ocean basins. These are the flattest and the smoothest regions of the world. The depths vary between 3000 and 6000 meters. These are covered with fine grained sediments like clay and silt. Oceanic deeps or trenches. The trenches are the deepest parts of the oceans, and they are relatively steep sided, narrow basins. They are some 3 to 5 kilometers deeper than the surrounding ocean floor. They occur at the bases of the continental slopes and along island arcs. They are associated with active volcanoes and severe earthquakes. As of now, 57 deeps explored, such as 32 are in the Pacific Ocean, and the trenches are the deepest parts of the oceans and they are relatively steep-sided narrow basins. They are some 3 to 5 kilometers deeper than the surrounding ocean floor. They occur at the bases of continental slopes and along its island arcs. They are associated with active volcanoes and severe earthquakes. As of now, 57 deeps explored, such as 32 are in Pacific Ocean, maximum 19 in the Atlantic Ocean, and 6 in the Indian Ocean. Minor relief features. Beside four divisions of the ocean floor, there are some minor relief features such as mid-oceanic ridges, seamount, submarine canyons, guyals, and atolls. Mid-oceanic ridges. A mid-oceanic ridge is composed of two chains of mountains divided by a large depression. Example, Iceland, a part of the mid-Atlantic ridge. Seamount. Seamount is a volcanic in origin with pointed summits and rising from the seafloor that does not reach the surface of the ocean. Example, the Emperor Seamount, an extension of the Hawaiian Islands in the Pacific Ocean. Submarine canyons. The submarine canyons are deep valleys. Sometimes they're found cutting across the continental shelves and slopes, often extending from mouths of large rivers. Example, the Hudson Canyon. Guyot. Guyot is a flat-topped seamount. Approximately 10,000 plus seamounts and guyads exist in the Pacific Ocean. Atoll. Atolls are low islands found in the tropical oceans consisting of coral reefs surrounding a central depression. Distribution of temperature. The temperature depth profile for the ocean water shows how the temperature decreases with the increasing depth. The profile shows a boundary region between the surface waters of the ocean and the deeper layers. This boundary region from where there is a rapid decrease of temperature is called thermocline. About 90% of the total volume of water is found below the thermocline in the deep ocean. In this zone, temperatures approach 0 degrees centigrade. The average temperature of surface water of the oceans is about 27 degrees centigrade and is gradually decreases from the equator towards the poles. The oceans in the northern hemisphere record relatively higher temperature than in the southern hemisphere. The temperature structures of oceans over middle and low latitudes can be described as a three-layer system from surface to the bottom. First layer, it is the top layer of warm oceanic water and is 500-meter thick with 20 to 30 degrees of temperature. This layer within the tropical region is present throughout the year, but in mid-latitudes, it develops only during summer. Second layer. The second layer, called the thermocline layer, lies below the first layer and is characterized by rapid decrease in temperature with increasing depth. Its thickness is between 500 to 1000 meters. Third layer. This layer is very cold and extends up to the deep ocean floor. In the Arctic and Antarctic circles, the surface water temperatures are close to 0 degrees centigrade, and so the temperature change with the depth is very slight. Salinity of the ocean water. Salinity can be defined as the total content of dissolved salts in seawater. It is calculated as the amount of salt dissolved in 1000 gram or 1 kg of seawater. It is usually expressed as parts per thousand or ppt. The salinity of 24.7 ppt has been considered as the upper limit to demarcate the brackish water. Salinity generally increases with depth, and there is a distinct zone called the halocline where salinity increases sharply. High salinity seawater generally sinks below the low salinity water. This leads to stratification by salinity. Factors affecting the ocean salinity. Salinity, temperature, and density of water are interrelated. Hence, any change in the temperature or density influences the salinity of water in an area. Other factors are the following: evaporation and precipitation, freshwater flow from rivers, freezing and thawing of ice. Wind also influences salinity. Ocean currents contribute to salinity differences. Movements of the ocean water. Movements of the ocean waters can be classified into three: waves, tides, and ocean currents. Waves. Oscillatory movements that result in the rise and fall of the water surface. The raised part is the crest and the lower point is the trough. Tides. These are the periodical rise and fall of the sea levels. It occurs once or twice a day and caused by the combined effects of the gravitational forces exerted by the sun, the moon, and the rotation of the earth. When the tide is channeled between islands or into bays and estuaries, they are called tidal currents. Flow tide, rising tide or incoming tide. The time between the low tide and high tide when the tide is rising is called the flow or flood. Ebb tide, receding or outgoing tide. The time between the high tide and low tide when the water level is falling is called the ebb. Tides are divided on the following basis: frequency, semi-diurnal tides, diurnal tides, and mixed tides. Position of the moon, the earth, and the sun. Spring tides, neap tides. Tides based on frequency. Semi-diurnal tide. It is the most common tidal pattern featuring two high tides and two low tides each day. Diurnal tide. There are only one high tide and one low tide each day. Mixed tide. These tides having variations in height are known as mixed tides. Tides based on the sun, moon, and the earth position. Spring tides. These tides will occur when the sun, the moon, and the earth are in a straight line. The height of tide will be higher. They occur twice a month, one on the full moon period and another during the new moon period. Neap tides. These tides will occur when the sun and the moon are at right angles to each other and the forces of the sun and the moon tend to counteract one another. Normally, there is a 7-day interval between the spring and the neap tides. Advantages of tides. Tidal floats are of great importance in navigation. They help the navigators and fishermen plan their activities as they are predictable. Tidal heights are very important, especially harbors near rivers and within the estuaries having shallow boards at the entrance which prevent the ships and boats from entering into the harbor. Tides are also helpful in desilting the sediments and in removing polluted water from river estuaries. Tides are used to generate the electrical power. For example, in Canada, France, Russia, and China, it is used at a large scale. Ocean currents. The ocean currents are the horizontal flow of mass of water in defined direction over great distances, influenced by the rotation of the earth. A regular volume of water in a definite path and direction, it represents the ocean currents. Ocean currents are influenced by two types of forces, namely primary forces that initiate the movement of water, secondary forces that influence the currents to flow. Factors influencing the currents. The primary forces that influence the currents are the following: heating by solar energy. Heating by solar energy causes the water to expand. Therefore, near the equator, the ocean water is about 8 centimeters higher in level than in the middle latitudes. Wind. Wind blowing on the surface of the ocean pushes the water to move. Friction between the wind and the water surface affects the movement of the water body in its course. Gravity. Gravity tends to pull the water down the pile and create gradient variation. Coriolis force. The Coriolis force intervenes and causes the water to move to the right in the northern hemisphere and to the left into the western hemisphere, southern hemisphere. The secondary forces that influence the currents are the following: density and the salinity. Differences in the water density affect the vertical mobility of ocean currents. Denser water tends to sink, while relatively lighter water tends to rise. Water with high salinity is denser than water with a low salinity, and in the same way, cold water is denser than the warm water. Types of ocean currents. Ocean currents can be categorized on the following basis: based on temperature, warm ocean currents, cold ocean currents; based on depth, surface ocean current, deep ocean current. Advantages of ocean current. West coast of the continents in tropical and subtropical latitudes except close to the equator are bordered by cool waters. When coasts of the continents in the middle and higher latitudes are bordered by warm waters which cause a distinct marine climate. Warm currents flow parallel to the east coast of the continents in tropical and subtropical latitudes. This results in warm and rainy climates. These areas lie in the western margins of the subtropical anticyclones. The mixing of warm and the cold currents help to replenish the oxygen and favor the growth of the phytoplanktons, the primary food for the fish population. The best fishing grounds of the world exist mainly in these mixing zones. Current in the North Atlantic Ocean. You should remember the name of the current and whether it is a warm current or the cold current. Location is sometimes not that much important. North equatorial, warm, Cairn warm, Florida warm, Gulf warm, North Atlantic drift warm. Or you can just remember the cold ones and automatically the remaining will be the warm ones. Labrador, Erminger or East Greenland and Canaries are the cold ones. In the South Atlantic Ocean, South Equatorial Brazilian and the South Atlantic West Wind Drift are the warm ones, and Venezuela and Falkland are the cold ones. In the North Pacific Ocean, North Equatorial, Kuroshio or Japan or Kuroshio and North Pacific Drift are the warm ones, whereas the Bering, Alaskan, Oshotsk, Kuril and Californians are the cold ones. In the South Pacific Ocean, South Equatorial and East Australia are the warm currents, and South Pacific West Wind Drift and Humboldt or Peruvian are the cold ocean currents. In the South Indian Ocean, South Equatorial and Agulhas or the Mozambique and South Indian Ocean or West Wind Drift are warm, whereas the West Australian are the cold ones.